Hello, my name is Ihab Ashkar, and I'll be explaining depth-first search and breadth-first search. So imagine you're exploring a maze. You can either take one path and keep going down as far as you can with that path before you start turning back, or along the way you can start exploring different paths. These are two different graph traversals. One is depth-first search, and another is breadth-first search. Consider the graph that we have on the left. We'll start with depth-first search. A graph is just a collection of nodes, also called vertices. So each one of these are a node, and they're connected by edges. So these are edges. And traversal just means visiting the nodes of the graph. And so DFS explores one branch as far as we can go before we start backtracking. So let's say we start at start at A. We'll travel down to B, but rather than searching at any other node, we'll keep going down to D. At D, we realize that there aren't any other branches that we can go further down. So we would backtrack up to B, and we would go down to E. Now we realize that there are no other branches that we can go, so we backtrack up to B, and at B, there's nowhere else to go from B. We've already visited D, we've already visited E, so we can go back up to A. From A, we can go down to C, and then we keep going down into F. So the flow would look like this. We went from A to B to D to E, and we went back up to B, and then went back up to A, went down to C, and down to F. So this was our depth first search. This was the traversal order that we found with it. So let's look at BFS, breadth first search. Just a reminder, BFS, we are looking at the nodes each way we go, or each level down. So we're not going to go all the way down and then backtrack at the end once we can't go any further. We'll look at each node. Alrighty. So we can start at A, and then we'll visit every node that's one edge away. So we visit B, and then we visit C. Here, we'll just write it as we go. So we've been to A, B, and C. And so we went to B first. And so now we'll visit every node that's two edges away, or one edge from B. So we'll go to D, and we'll go to E. And so now we've visited everything on this side. And so we can go back up to C, and we'll visit everything that's one away from C. So we go down to F. And this is the order of our traversal with BFS. And just for some background on when to use each, you would want to use BFS when you need the shortest path in an unweighted graph, meaning the edges don't have any weights attached to them, and it would cost the same to go down each path. For example, if you want to find the fewest number of friend connections between two people, or the fewest moves in a puzzle, because BFS visits nodes each level by level, the first time it reaches a node, it has already found the shortest path in number of edges. You would want to use depth first search when you need to explore structure deeply. If you need to detect a cycle, or if you need to explore connected components, or if you need to, if you have a backtracking problem. Keep in mind that there are two data structure differences between DFS and BFS. DFS represents a stack, while BFS represents a queue. So since we are backtracking, we are adding each value that we are going to our stack. And we are backtracking so we can remove that value once we've already visited it. But with our queue, we're not backtracking. So we add the values as we see them since we're going level by level. And that is all. That is the simple difference between DFS and BFS.